So, hello, dear students. Today we'll solve one problem. This problem is based on optics. Uh, this problem is from class 12th ISC board 2024 problem. The problem is like this. The figure below shows a ray of monochromatic light alum incident on the first surface AB of a regular equilateral glass prism. So here just this word is important here. This is equilateral glass prism ABC, and the emergent ray uh, grazes the adjacent surface AC. You can see in the figure, this is surface AC, and you have to calculate the angle of incidence. Refractive index of glass is given 1.5. There are two mediums, one is air and another is glass. So we have to calculate the angle of incidence here. Actually, there is little bit uh, error in the figure of this question. Here m is not here. Here m is here. It is like this. Lm. There is one light ray only, Lm. And students, this is normal, and this is angle of refraction R1. Here the light ray Lm is undergoing refraction at the first surface AB of the prism. So here R1 is angle of refraction at the first surface AB. And students, here it is angle R2. R2 is the angle of incidence at the surface AC. And here the emergent ray is grazing along the adjacent surface AC. Here angle of emergence is, it is 90 degree. It is 90 degree. So I hope these all notations are clear. So students, we have to calculate the angle of incidence here, and this is an equilateral triangle. So here angle of prism, that is here solution. Angle of prism is angle of prism. It is 60 degree. And students, refractive index of glass, it is given, and it is 1.5. It is given in your question paper also. And students, first we will use Snell's law at point N. First we will use Snell's law at point N. So here, using Snell's law, Snell's law at N. Snell's law at N. So here it will become 1 upon 1.5 is equal to sine R2 upon sine E. Actually, most of the students got confused in applying Snell's law. So here I am just explaining it. Students, general form of form of Snell's law is n1 into sine I, n1 into sine of angle of incidence, it is equal to n2 into sine of angle of refraction. Students, here n1 is refractive index of first medium and n2 is refractive index of second medium. And students, here in our problem, if you will see carefully, here R2 is the angle of incidence at the surface AC. So here R2 is angle of incidence. So here I will be equal to R2. And students, here we are applying Snell's law at point N. So here N1 is refractive index, refractive index of prism, and material is glass. In the problem it is given refractive index of glass and prism is of material glass, and it is 1.5. So students, it is 1.5. And as you all know, N2 is refractive index of air and it is equal to 1. So students, here if you will apply Snell's law at point N, so here N1 into sine I, and N1 is refractive index of glass. So 1.5 into sine R2, and it is equal to the N2 refractive index of air 1 into sine of angle of emergence. And students, if you will simplify this, it will become 1.5 is equal to sine of angle of emergence upon sine of R2. And students, if you will take reciprocal of this, it will become 1 upon 1.5. It is equal to sine R2 upon sine of angle of emergence. And students, in our problem, it is given. If you will see the figure carefully, angle of emergence is 90 degree. So here we will put E is equal to 90 degree angle E. So here it will become sine 90 degree, which is equal to 1.5 further On simplification, sine R2 is equal to 1.5 into sine 90 degree. And students, sine R2 is equal to 1.5 into 1. So here sine R2 is equal to 1.5, and the students, R2 will become sine R2. Here we will convert this in fraction 15 upon 10, and if you will cut by 5 it will come out to be 3 by 2, and if you will divide it will come out to be 0.67. And students, R2 is equal to sine inverse 0.67. And if you will calculate this, I'm calculating it by with the help of scientific calculator. Students, now we will apply Snell's law at point M, as you can see the figure. So here Snell's law is will apply, and it is equal to n1 into sine of angle of incidence, which is equal to n2 into sine of angle of refraction. And students, if you will see here at M, the light is going from air to denser. So here first medium is air and second medium is glass. Glass is a denser medium. So students, here N1 is 1 and N2 is 1.5. Angle of incidence is I and angle of refraction is R1. So students, here we will apply it. So here 1 into sine of angle of incidence, which is equal to 1.5 into sine of angle of refraction, sine R1. So here sine of angle of incidence upon sine of angle of refraction R1, it will be equal to 1.5. And students, we know one relationship between angle of prism R1 and R2, and it is A is equal to R1 plus R2. This derivation is given in your book, students, and if you want, I can derive this on my YouTube channel. So if you want, you can comment. So students, here A is angle of prism and it is 60 degree, and angle of R1 is angle of refraction at the first surface. We have to calculate this, and we have calculated now angle of refraction at the second surface, and it is 42 degree. So students, if you will simplify this, it will come out to be 18 degree. So here we have got angle of refraction at the first surface, and it is 18 degree. So students, we will keep this value 18 degree in this equation, and we can calculate angle of incidence. So yes, sine of angle of incidence, sine I upon sine 18 degree, which is equal to 1.5. And students, sine of angle of incidence, it is equal to 1.5 into sine of 18 degree, and sine of angle of incidence, it is equal to 1.5 into sine of 18 degree. And if you will simplify this, it will come out to be 0.45 on right side. It is 0.45. And students, here Angle I will become sine of inverse 0.45 degree. And students, if you will simplify this, uh, you can calculate this value with the help of scientific calculator, and it will come out to be 26.74 degree. So this was the solution of this problem. And if you like my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.